Hi, my name's Jordan Marshall and I'm Special Projects Editor at Building Magazine. I'm so delighted to be hosting the first session of Net Zero Live November 2023. It's a great program over the next few days, jam-packed with amazing CPD certified webinars and exclusive thought leadership pieces. And I'm really happy that I get to host the first session today, which we're running in conjunction with Rockwool. It's entitled Mind the Insulation Gap, Why Stability and Continuity are Key for a Long-Term Performance. We've got a great panel who I'd love to introduce you to. So first up, we have Professor Will Swan, Director, Energy House Laboratories at University of Salford. We also have Rupert Daly, Associate Director and Passive House Designer at John Gilbert Architects, and James Francis, Product Manager and General Building Insulation, Rockwool UK. Just a couple of things from me before we jump into today's session. Yes, I want to answer this question up front. This session will be available on demand. Give us about an hour after the conclusion and it'll be available via the same link you've joined today. So please feel free to distribute that with your colleagues who you think it will be useful for after the session or rewatch to catch up on things. Secondly, we really want the audience to get involved today. So please send through your questions at any time and then we will get to those in the Q&A portion of the session. That sort of leads me to discuss how today's session will run exactly. Each of our presenters is going to provide an introductory presentation on the topic, outlining their thoughts and key points on the topic before we move on to the Q&A panel discussion section in the second portion of today's session. That's really enough for me. It's time to get over to the experts. So Will, I'll hand over to you to kick things off for us.
Thanks, Jordan. Just bear with me a second while I share my screen. There we go. So, as slick as I can be. There we go. As Jordan said, my name's Will Swan. I'm the Director of Energy House Laboratories. For those of you that don't know us, we're a sort of across the board domestic energy research and innovation unit. So we cut across fabrics, systems, controls, emitters. We've been around for sort of around 14 years or so. And what we do, I suppose our unique offer is testing whole buildings under controlled conditions. So some of you may be familiar with the original Energy House, which was constructed in 2011. And I'll talk a little bit about the work we've done there, because obviously there's been, a decade or more of work in there. And our recent Energy House 2 facility, which sort of scaled up the original principle. So the reason we decided to go this way is, and certainly around 2010, we were looking at things like the Green Deal, CESP, and we saw there was an opportunity to look at existing homes. And I think still retrofit, particularly for the insulation market, is still a massive challenge. And what we identified is there was a problem of assessing retrofit solutions, because really, there's two ways of doing it: taking a piece of insulation and testing it in isolation, which we know is not really the problem. The insulation almost invariably works in that context. Or doing a field trial, which can be really expensive, can be difficult to do, intrusive in people's homes. So what we can do is conduct repeatable experiments by controlling the temperature. So we can keep the temperature at a fixed state, unretrofit the house, retrofit the house, two different states, and test them under exactly the same conditions with high quality data. And also this gives us the opportunity is also look at things that may not be proven as yet, or even look at the impact of defects. So we first started our first major project in retrofit was with an organisation called Saint-Gobain. They're the world's largest manufacturer of construction products. And this was really to do a whole house retrofit using a variety of products. And what we did with that was to completely retrofit the house, baseline the house, retrofit the house, and take one thing off at a time to see the impact of the varying interventions. And this for us, is a great learning experience to try and understand what worked, how we measured things. And we've definitely moved on since then. And I think just to really recap, we think measurement is really important. I think some of the problems that we see in the sector are that we rely sometimes not on measured data and not on a full understanding of how things actually perform in the field. So, we have a number of areas where we think we can bring real value. So first of all, does the retrofit meet design predictions? And you can see a whole house retrofit that we've done. Are remedial works required? Will paybacks be achieved? Is the ventilation strategy correct? Is the air tightness of a dwelling appropriate for the ventilation strategy? And issues around health risks. So pre-existing risks, have we introduced new risks? Surface condensation and mold growth, overheating. And so understanding by measuring what those risks are and actually coming to appropriate solutions for homes is really very much at the heart of what we do. And we do this really in two key ways. I think the first is really understanding the whole house heat loss, so the overall performance of a retrofit. And that's some around thermal bridging. Where are the linear thermal bridges in the install? Understanding plane elements and how they perform, understanding infiltration and air permeability. And this gives us, so we have a number of methods, and there are a number of new methods. So there was a recent project from DESNZ called SMETRS about how we can measure houses and understand that they're actually performing in the way that we want them to. So that kind of whole house heat loss can give us a single number of all the losses and can give you quite a good understanding of how the house performs in the round and to see if it's meeting its design expectations. The other element that we look at is obviously thermal bridging and the junctions between the thermal elements. So what we see is, sometimes the relationship between product and install, or product detail design and install, is essential. And I think what we do, that gives us the opportunity to look at how that detailing can be done and then how it might be delivered on site. So we can see there, obviously, we use a variety of tools. So we'll use, the standard, things like blower door tests, but we'll also use things like pulse tests. We'll use thermography. We use co-heating, U values. So we get this very, very data intensive full picture of what we're trying to do. So you can see here in some of the examples that we've given here, this is the original there. There we can see the thermal bridges that occur from the design and delivery of a retrofit. So we've just finished a big piece of work. The report is not out yet. It will be out before the end of the year. So in that project, we did 20 different retrofit scenarios. So there were 4 retrofit scenarios and 5 heating scenarios, all done in combination. So some of the initial findings with the real detail will be coming hopefully before the end of the year, and if not in January. I think the whole house approach does reduce the risk as compared to piecemeal retrofit. And I think the issue in terms of payback, it's very difficult to convert those paybacks into space heating energy savings, but actually we should be looking at the co-benefits in terms of quality, in terms of the safety and health of the house. Some whole house measures, let's skip forward there. Some whole house measures are not required, and they did add some cost to the retrofit. And in some respects, in delivering retrofit, really understanding what is necessary and what works is really driven by understanding the actual performance of things rather than necessarily sometimes quite light touch model performance. I think existing piecemeal retrofits can be converted to whole house retrofits. I think piecemeal, and in some respects, is not completely off the table, but there has to be an awareness of the thermal envelope and air tightness barriers. So some of the work that we're doing is to try and understand what is appropriate, and in some respects, we suffer from under design, but we can sometimes suffer from over design as well, which actually adds unnecessary cost. And particularly if we're going to get into the owner occupier market, that's a big issue. We're not just doing retrofit, although it's a big part of our work. We're currently in Energy House 2 looking at 2 future home standards buildings. So we're working with Bellway, Saint-Gobain and Barratt. and we're looking at the performance of those properties as against the new standard that I think is due out of consultation in a few weeks. And that to us is really important, because I don't think it's been something that the sector has done to say, we're going to build this, does it work, how can we improve it, what are the installation risks? So we'll be doing baseline testing at the moment, and that will be out very shortly. So that's looking at U values, aggregated heat loss, air tightness, and using that data to understand where the work needs to be done better. This measurement also gives us an opportunity to build much better models, so more accurate models, because even some of the dynamic models, the assumptions within them can be incorrect. So I think largely the message I'm kind of trying to give is actually measurement's getting cheaper. There are places that do it really well. I like to think we're one of them. And actually giving that evidence to the sector about what the right thing to do is essential. And I would say, everything we do is with industry. And, we work with Rockwool as well, and to kind of understand how things are performing and how we can better deliver net zero, affordable, energy efficient and healthy homes.
Brilliant. Thank you so much, Will. That was a great way to kick things off. Rupert, I would love to ask you if you could give us your introductory presentation next. Also, just a reminder to our audience, yes, the session will be available on demand if you want to check anything. And that sounds great. Okay, Will, thanks.
I'm just going to open this up so I can see. The presentation's disappeared, so I can't actually see it at the moment. There we go. Thank you. Okay, so hi everyone. I'm Rupert Daly, a Passive House architect with John Gilbert Architects. I'm also a Passive House trainer with Coaction. And really where I come from is social housing market for the last 20 years. And the reason that we've moved towards Passive House is really to get things to actually function or work in the built environment to how they've been designed. We found there's quite a lot of performance gap. And we're working with partners Best to provide practical training on how we can upskill the industry to understand what the issues are and how we can design them out and build them to meet the design. So two things there, the crossover between design and construction. So designers needing to design for buildability to make it mitigate the risk on site, and then builders to take that starting point and make sure that what they're actually building follows what was actually designed. So we try and reduce down the performance gap. Okay, thanks. Next slide. Thanks. Okay, so I've sort of given the introduction there already, so I'll go on to the next slide. Thanks. So at John Gilbert's, we've been doing sustainable architecture for a long period of time, along with conservation and retrofit. A lot of what we do, we're interested in how the buildings perform, so we set up Hab Lab as well. So we do a lot of post-occupancy evaluation, understand how the buildings actually perform in reality. And in the retrofit work, especially at the moment, we've seen a great interest in housing assessment or stock assessment for a lot of social housing providers to understand how we're going to get to net zero, how we're realistically going to implement the works, deal with works that have already been done but potentially been done badly, and prioritize the cost-effective retrofit of our buildings. Next slide, please. So as I mentioned there, a lot of the ethos and what we work with is using a methodology called Passive House methodology for both new build and retrofit. And this is, as a tool, allows us to analyze in a sort of functional way as designers, as well as sort of implementing the works that doesn't bed us down too much in the data. The data is useful, but on the at the coalface, if you like, on the actual construction projects. We need to be able to implement that in an effective manner, and it's a simplified method which has a lot of background data in the more dynamic modeling and simulation and post-occupancy information. Okay, next slide, thanks. Okay, so focusing on the insulation, the Passive House methodology has quite a few different aspects to it to radically reduce down the space heating demand. But today I'm just going to focus primarily on insulation. So what we're looking for, if we take a building and we look at the overall plan or GA sections, we're looking for insulation continuity right round on the plan or the sections. And that means that the insulation has to have no gaps. So in reality, what we end up doing is, as designers, we design on the basis of the performance of the actual product, how it goes together, assuming that there's no gaps. In Passive House, we're looking for no gaps between it because we know that ends up being a performance gap. So if we take this as an example, the insulation is a kit of parts. In order for that insulation to function, then we need to make sure that it's adequately protected from the elements. So we have wind tightness to the insulation, and then we have air tightness protecting it from the moisture, if you like, or the building fabric from the moisture drive to the outside. Okay, so if we're, as designers, if we're using any methodology really, we're basing it on the assumption that it's put together. So if we go to the next slide, if we start to think about potential gaps in that insulation continuity, you can immediately see by the thermal bridge diagram that we get a lot of additional heat loss. So this heat loss isn't included in our design assumptions. So we need to try and mitigate it wherever possible. I think in Passive House, we're really trying to go for no gaps. There's a reality of sites where there is practical tolerances. So 2 to 3 mil is an absolute. Anything bigger than that, it needs completely filled. Okay, so a through gap here, you can see the heat loss direct through to the structure. So it's quite a significant heat loss. One of the tools that we've got, if I can go to the next slide, is trying to break that direct connection from outside to inside. So even if not being specific to the type of insulation, but if we can break that air path directly through, then you can see there that we've got a significant reduction in heat loss. So by layering up the insulation initially, then in design parameters, this looks quite good. The reality is that thermal bridge gap that we've got there might be reasonably insignificant on its own, just to a localized area. The risk is that gap joins another gap and joins another gap, and we get lots of different veins of heat loss running through the insulation. Okay, so next slide. There's some really good work done on this. It's available on the Passive House Trust website by one of our co-practitioners at Coaction, Mark Siddle, and looks at the effects of thermal bypass. So there's quite a lot to it. There's a really good report. If you suggest you take the link here and have a read through it. But the impact or the devastation, if you like, on the performance of insulation by thermal bypass can be quite dramatic. You know, if we've got a design value, depending on the type of bypass there, but you could be 500% more heat loss than what's actually in the design if we've got it poorly implemented. Okay, next slide. So some examples of this, and this is where we start to think about different products for different uses and how we can actually put these together. So thinking about substrates critically, you know, if we're going to be using rigid boards, how can we actually get those smooth onto a substrate so that there are no air gaps? You can see here finger width air gaps between substrate masonry as a result of mortar snots. The alignment of that block work, if you've got a long rigid board, how you're going to get that on. Essentially, if that gap there links to a gap through the insulation, then you've got a full bypass going on. The middle picture is a retrofit. So left hand is a new build, middle picture is a retrofit, actually taken yesterday, where the substrate wall is a masonry wall which isn't smooth. And we've got this is something that's happening a lot in the industry, or has been for a number of years, where we've not fully appreciated what the impacts of these air gaps are. So ideally what we want is a nice smooth flat surface for all of this type of insulation to be applied to. The last picture there is just another thing where we're looking at, if we're going to do this work, we want to do it once and we want it to last for the lifetime of the building. So this example here is just some products, when they go in, they're still maturing and there's potential for shrinkage. So where a gap might have been installed tight, it can actually open up slightly over a number of years. So we've got to be careful that the products are fit for purpose for the lifetime of the building. Okay, next slide, please. So how do we do that? Well, we need to think about the specification, the types of products, the densities of the products, how they can knit together, how they can interface to other geometry and components in the construction. So this example is from one of the projects that we've done through SUST for other architects for the Passive House schools projects that are happening in Scotland at the moment. And we can see an overlap here of the insulation layers, so staggered jointing, and a tight fit, because the insulation, whilst it has its own rigidity, it's flexible enough to actually squeeze around all of these profiles. So it's good. There's no performance gap relative to what's been designed, which is what we're aiming for, but there's still room for further improvement. For example, in this build up here, there's a reasonable amount of off-cut material wastage, partly as a result of needing the battens there to get to the wall ties, to get to the outside for the overall thickness that was required for this actual building to meet the demand. Now products are getting developed, so we could do this with a newer, longer wall tie, which didn't exist at the time, and take away the battens, and more continuity means we might be able to down the overall amount of material that's needed in the first place. Okay, next slide. It's not only about the products, it's also about the specification and the installation. So knowing which products work well with certain construction types. So in this example, we have timber I-joists used as a support frame for the insulation. There needs to be a bit of thinking about the geometry that's for that. Is the insulation flexible enough to get around the gaps at interfaces, and also can it be cut, or it can be cut obviously, but getting it cut effectively, neatly, accurately on site is quite important. The last picture here is really thinking about where it often emanates from, which is the condition of the substrates. So if we have a rigid board requirement, the absolute sort of flatness of that substrate is critical to getting the boards to actually interface with each other and align up with the adjacent components as well. Okay, next slide, please. So we've got to think about how we ensure that the workforce can actually implement this work. So we've got skilled workforce, we've got semi-skilled workforce, and thinking about the right tools for the job, training the people to understand what is important about insulation. We don't just throw it up there into a gap. It needs to fit nice and snugly. We can do really with the proper and suitable insulation products. We can actually get these cut on site with relatively basic tools if there's a reasonable level of skill and care involved. There are other tools available which are more specialist, which can also help facilitate the accuracy of cutting. But beyond that, maybe we need to take a step further back and say, well, how can we actually reduce risk by minimizing the need for cutting in the first place? How much time and cost can we save on projects if we can just take them straight from the packaging and implement them straight onto the construction with minimum number of cuts to get around the spacing for timber joists, for example, or cutting around perimeters, etc. Okay, next slide, please. So what we're doing with Coaction and at Best in just outside Glasgow as a training facility is looking at that point at which we transition from design into construction. So we're bringing together and we're collaborating between design teams and construction teams and having those discussions around various small rig builds. So we're taking the team through from, say, construction level drawings, looking at how you would sequence those, implement those, and then actually getting hands-on as a team to understand what's not communicated in the drawings, but what is actually important to ensure that we get this installation continuity. And then also the impending issues that we've got with time and cost as we try and improve performance. How can we minimize material wastage, labor time on site, and effectively bring in higher performance at a lower cost? Okay, next slide, please. Then also, as a part of the methodology for Passive House, we've got third-party verification. So what gets designed gets assessed by an independent certifier. What gets built, the contractor needs to provide site evidence to ensure that that site, what gets built, reflects what was designed. So we're critically important is that it's not just a paper-based exercise to meet a particular national standard. It actually delivers what it can in reality. So having this third-party certification and this crossover of evidence and communication between design teams and contractors is all part of the team exercise and collaboration. Okay, thank you. Next slide, that's me. Thanks very much.
Brilliant. Thank you so much, Rupert. That was another great presentation. Now, James, if I could ask you to round out our initial introductory presentations today, and then we'll get into the Q&A after that. To our audience, I can already see there's a few questions rolling in, so please keep those coming through and we'll try and answer off as many of those as we can in the session, on the second part of the session. Okay, thanks, James.
No problem, just try and share this. Apologies, having difficulty sharing the presentation.
Okay. We'll sort it. One of us will do it. Celine's got those up for you.
Okay, thanks. Okay, so yeah, thank you everyone for joining us this morning. Firstly, I'd like to thank William and Rupert for the insightful presentations. Thanks for that. I think it's vitally important that manufacturers like Rockwool engage with the industry on this important topic. And we are very proud to be part of this discussion this morning. If you could go to the next slide, please. So the performance gap is not a new topic, yet it's something the industry is still trying to tackle. There's a lot of research demonstrating this issue between predicted and as-built performance, and something's often referenced in technical studies is the work by the Belgian professor on the effects of what he calls thermal looping. In his study, he found that an air gap as small as 6 mil is enough to increase the heat transfer by 158% of the design value. He did conclude, however, that could be addressed through correct application and the importance of installation on site. And 3 decades on, the message remains just as relevant today as it did back then. Next slide, please. So this morning I'm going to cover 3 main topics. I'm going to share our insight into the performance gap and the role of insulation, how that can support the country's ambitions to net zero. I'll be sharing insight into new evidence that we've obtained from scientific studies demonstrating how stone wool insulation can help naturally reduce the performance gap. And I'm pleased to share evidence from case study research we've obtained from Copenhagen Airport demonstrating the long-term performance of stone wool. Thank you. Next slide. So just to start off with some context, it's well documented how net zero places greater emphasis on the fabric of a building. And as we look to decarbonise the grid, our building fabric needs to work harder for longer. We see this addressed through recent uplifts in thermal regulation across the devolved nations. Under new regulations, for instance, in England, we know CO2 emissions from new build homes must be 30% lower than previous standards. And then with the introduction of the Future Home Standard, low carbon heating systems, it's important that buildings are designed with high levels of energy efficiency to ensure the heat generated stays within the home. Next slide, please. So to ensure the government will meet its net zero commitments, it's essential that any new homes planned and delivered now will not need a significant upgrade by 2050. And that requires many new carbon homes to be built, and they must perform as expected. Insulation combined with other energy measures plays a major role in reducing the energy consumption of buildings. And by improving insulation standards, building owners can ensure that they reduce their operating costs while making buildings more sustainable and comfortable to live in. Next, please. So when we've done our research to putting this presentation together, we've looked at many different literature reviews, and we've found that research by the Carbon Institute Trust, there's a temptation to install as many low carbon technologies as possible, where simplicity should be the aim of the design. It's also important that low carbon technology will only work if the fabric is performing. So, looking around the literature review, design should focus on eliminating thermal bridging where possible and eliminating gaps. We know that anywhere that air can enter or escape will reduce the overall thermal performance of the building. Next slide, please. And many new homes are expected to transition to heat pumps, potentially increasing energy costs. And research indicates the unit cost of electricity is 3 to 4 times higher than gas. And that's going to result in higher fuel bills, of course, placing even more importance on the fabric of the building. Next, please. So at Rockwool, we advocate for a fabric first approach, getting it right first time. But if we look at the effects of incorrectly fitted insulation are quite staggering. We know it's a common issue, and the tests by the BRE back in 2008 indicate that poor installation can in fact increase the U value to as much as 310%. The common areas that we find are gaps forming between insulation, lack of insulation and continuity junctions, poor insulation in lofts, and debris and mortar snots forming in the cavity. These are often areas not visible to the homeowner, but these are going to have long-term implications of the fabric of the building. Next, please. So that was, I think, what can we do about it? So summarized nicely in Tom Dollard's new book recently that even though designs might look good in AutoCAD, they might be difficult to achieve in reality, and often solutions are products that are easy to install. I think there's a lot of good work done on this, looking at robust measures and easier installation processes, and it's helped partly by Part L guidance with photographic evidence, and supported by new standards like the building performance evaluation. Next slide, please. So with that in mind, understanding the impact of gaps was key for us here at Rockwool, and in response to this, we've conducted our own investigation to the performance of Stonewall and its natural ability to reduce the performance gap. We wanted to learn two things. We wanted to see what was physically happening when two pieces of insulation joined together and what impact that had on thermal performance. So as a result, we've conducted a series of tests and studies to replicate the impact of gaps in the insulation layer and the effect of thermal performance. Next slide, please. So the first part of this was to analyze the material at the microscopic level. When viewing the two slabs under a microscope, we can see quite clearly there's an initial gap. And if we click to the next slide, we can see when these slabs are gently pushed together, we see that initial gap close. So effectively what's happening here is two pieces of insulation knitting together, and in turn, that's providing a continuous insulation layer. So we proved that it's working, and what we've done then, we've sent samples to the thermal lab at the University of Salford, and the results of these tests show there's no thermal loss of performance between a whole piece of insulation and cut piece, and that was across a range of densities. What we concluded from the study is when stone wool slabs are tightly joined together, the edges knit together, that provides a continuous insulating layer with no gaps and no associated loss of performance. The results of these studies are summarized in a technical paper and will be publishing shortly after this webinar. So earlier I mentioned at Rockwool we advocate for a fabric first approach, getting it right first time. And that's only effective if the materials you're using deliver a long-term consistent performance. And that's going to be key if we're going to hit our net zero commitments. For continuing performance, dimensional stability is key. And why? Well, building materials naturally expand and contract over time, and that can lead to the formation of gaps and voids. Stone wool maintains its shape and properties over time and has the resilience to accommodate building movement. And if we go to the next slide, we've recently found a great example of this during a renovation project, Copenhagen Airport. This hangar was built in 1958 with 75 mil of insulation in the facade. And that is the oldest sample of stone wool product we have in use. The previous one was 55 years. Our team in Denmark worked with the Danish Technical Institute, and they carried out several tests. And what they concluded was after 65 years, the performance had not diminished at all. And it was as good as the day it was installed. So I'm just going to summarize to the next slide. Thanks for the opportunity to present to you this morning. We just covered very briefly the performance gap and the role of insulation. I've shared some insight into how stone wool can naturally reduce the performance gap and the case study from Copenhagen Airport. We have a CPD available in the new year that goes into this topic in a little bit more detail. So if anybody would like to join that, please drop a comment in a chat box and we'll pick that one up. Thank you very much.
Brilliant. Thank you so much, James. And again, thanks to Will and Rupert for your presentations as well. Let's get into this Q&A. I've got plenty of questions to kick things off with. But one that had been, that occurred to me is something that I want to pick up with all of you. Sorry, I'm just pulling up my notes. I was typing away furiously while you guys were all giving those presentations. So one of the things I did want to ask about was, you've all spoken about, considering the long-term implications of the performance gap in insulation, how can the industry best balance innovation and reliability in material specification, particularly to ensure sustained performance post-occupancy? There's been a lot of talk about innovation and that sort of thing, but how do you balance those two different levers, I guess, is my question. Does anyone have any particular thoughts? I don't want to pick on anyone.
I mean, I don't mind because we do a lot of measurement, and I think the performance gap is kind of, it's not just we've modelled it, we measure it, and there is the gap. We've done work on actually the models have gaps, and measurement has gaps. All measurement has uncertainty, so it's probably a bit more complicated than here is the SAP, here is the measurement, or it's wrong. You've got to kind of understand the nuance about what you're doing. But what we are seeing is things getting cheaper. So even if you're not, within 5% measurement error or 10% measurement error, what you will understand is what needs doing a lot better. So I suppose the big interesting area for me is certainly the Smeaton's type products. So there's quite a few out there. There's Smart HTC, there's Veritherm, there's Cube, and there's more coming all the time, which is basically to quickly ascertain the whole heat loss of the building. Now, if you combine that with a couple of other things, that thermography can be reasonably cheap, and again, thermography is something you can do very badly. You can kind of understand that. So some of those, which rely on things like smart meter data, you can use for that in use and see if there is a decline in the performance of the building going on. And I think once the price point gets quite low, then you might see these sorts of things just dropping in, like an air permeability or a blower door test, which we have to do now anyway. If you can get that down to a few £100, actually, do we need to sample big retrofit projects or big developments to really understand what's going on? And some of those you can do in occupation over a longer period. So there's a lot of opportunities in measurement and helping us understand not only, it's just been built, but what happens in the longer term as well.
Brilliant. Did either of you the others have a view on that?
Yeah, we welcome work on this area at Rockwool. We've seen advances in this area through the introduction of the Building Performance Evaluation Standard, and I believe the Future Homes published guidance on this area. But we believe there's no better proof than real-world testing. We've taken product out of buildings, and we've proven that the material still works after a consistent number of time. And from an innovation perspective, we've invested heavily in bringing out new technology. We've got new rock technology in terms of bringing out a better lambda performance product. That's basically more modern technology. It's the same stone wall, and we're confident that our products are going to be lasting well into the future.
Brilliant. Rupert, did you have anything you wanted to add? Or?
Yeah, just reiterating a little bit there. I think we can do a lot of analysis. We don't want paralysis from analysis by looking at, but I think we need to do more in that field, and we need to disseminate more on that as well, because we know that what we're building at the moment is quite possibly due for another retrofit in not too distant future, because we're not doing it 100% right, and we don't necessarily need space age technology to get us there. We just need fundamental good principles, I think, on building quality. But so just from my presentation there as well, really just saying that getting the understanding in the industry and the training and the knowledge, and then using some of these performance tools, these air tightness tests and thermography, as ongoing site tools for quality, as opposed to simply a compliance tool used at the end, really improve the performance as we go.
Brilliant. On that sort of skills and training knowledge point that you've raised there and in your presentation, Rupert, one of the things I did want to sort of pick up with you all is, and I suppose you use that phrase, paralysis from analysis, and you can have all the data and know how everything should be done, but how do we sort of overcome that? This is, if the product is installed perfectly, this is what will be, and everything's joined. How do we actually upskill? How much upskilling is needed so that things can be delivered as specified, I guess, would be how much of that is down to the installation? How much of that is down to, making sure there's the correct knowledge base out there?
I'll go for that. Initially again. So there's two things here. I think as a industry, I can see upskilling and training happening now, and it's scaling up quite quickly, which is good but it's also possibly at the upper ends where there's funding available for it. It doesn't have to be rocket science. What we need to achieve is quite fundamental basic principles, and we need the industry to be set up in such a way that that's what we're trying to achieve. Whereas at the moment, policy, procurement might be guiding us in a different route, which is more a race to the bottom, the cheapest price wins. So we need to actually somehow build in mechanisms that reward performance as opposed to getting the job done quickly, badly, and cheaply.
Absolutely. Will, James, did either of you have any thoughts on that one?
I mean, yeah, I kind of agree. Sometimes we sort of think bad buildings or bad retrofits are just a course of what goes on site. It kind of reaches back into, you know, people being paid by the square meter, and actually everything we've said is about, you know, joins and details and quality. If you're paid by the square meter, you'll get it out there, you'll render over it, and you'll move on. And I think some of that is about the big program. So we think of things like Fishwick, you know, where the remedial works weren't done, things were done at the wrong time, no detailing. So we set up some of these failures quite early on in our decision making, you know, right back to the way we fund them. And then also, I think that then sort of stop-starty, skills come, skills go out of the industry. So that kind of consistency of what, being clear about what we want as a country, and I think this runs to policy, and then putting the infrastructure in place that is consistent, and then the work draws those skills through. There's little point in training people if all of a sudden you're not doing any retrofits anymore. And that has been, you know, the last decade stop-start. That we need those skills to consistently build and remain in the industry, and we have to kind of do that with a mixture of private sector and public sector. I don't think we can drive everything with grant funding.
Brilliant. James, did you have anything you want to add? Or
agree with both points. You know, we advocate for getting it right first time as well. You know, it's expensive retrofitting. We support the industry with extensive technical services and installation guidance. And just commenting on, you know, a comment I made in the presentation, you know, even though designs look good in AutoCAD, you've got to consider the site workers and the materials they're using. Are they easy to work with? Is it onerous amounts of taping and things like this? So, and with, you know, the skill shortages in the UK, products need to be easy to work with. So yeah, that's our approach to this area.
Brilliant. Okay, so one of the other questions I sort of wanted to tackle was, you know, obviously embodied carbon is part of this discussion as well, and how you know, weigh up how does embodied carbon sort of play into this discussion? Obviously we're talking about that performance gap and everything, but it does still, the embodied carbon is still part of the overall net zero picture. How do the two sort of interplay with each other?
Yeah, a question I get asked quite a lot by architects, actually. You know, our approach, considering how embodied carbon is important, but it's essential that the availability of carbon data is there. To date, there's no generally accepted way to report this. You know, our reflection on this at Rockwool is that embodied carbon requires a life cycle stage approach. But that aside, our products at Rockwool have a huge net benefit when it comes to carbon emissions over the lifetime of its use. For example, the building insulation sold last year will save 100 times the carbon emitted in its production. But it's clear the industry are looking at embodied carbon and decarbonisation. At Rockwool, we've set pretty ambitious carbon and decarbonisation targets to reduce factory glasshouse green emissions by 38% by 2034. So there's a lot we are doing. We've seen a good effect that's had on EPDs during 2015 and 2020. We've showed 24% reduction in embodied carbon.
Brilliant. Did either of our other participants have a view on that one?
If I can just jump in there with a couple
absolutely.
of bits. So, you know, we've been doing quite a lot of operational carbon and embodied carbon analysis, and whilst embodied carbon is important, I agree that if we don't tackle the operational, it's sort of not going to have much of an impact. The other thing is actually looking, if we're doing new builds, or even surprisingly perhaps in retrofit, is actually trying to do more with less. So if we've got less material, you know, and that's one of the key things on the Passive House methodology is looking at the low-hanging fruit, or the easy things to do, and that's reducing the heat loss area. You know, so if you can get a fabric form factor better, so you've got less area to actually have to insulate in the first place, then you know, we can before we get into the EPDs, we can actually reduce down the quantity of material needed, for retrofit or for new build, and start designing and building more efficient shaped buildings.
You mentioned earlier, Rupert, that you had some offcut wastage from some passive house designs. What is the percentage?
I don't know typically, but we had just some feedback on one passive house school that we've been delivering, and on the Rockwool products that we used there, it was surprisingly quite high. It was about 20%, which
and that was just offcuts, was it?
It was offcuts, but part of it is thinking about getting the modules to fit the construction components. So where you saw those images with the timber battens, we need the spacing of those wasn't necessarily aligning to the thickness or the widths of the modules of the installation. So there's a bit more that can be done to improve that, so that you don't have to cut it before you take it. You can take out the packaging, put it on the wall almost directly. But there was also an element there on trying to achieve the quality that we were looking for. So if there was any badly cut elements, there's a bit of skill requirement there on site. But also if there's any damage to the products, then we're looking to make sure that what's going in is fit for purpose. So we need to make sure that the materials are adequately protected before they go in as well. So there is, I think, one of the challenges I've kind of set myself really is if you can design the buildings to work with the modularity of the products that are there, and seriously reduce down we're not going to get it 100% right, but if we can get most of the installation installed with minimum cutting, then, we're not only saving material, we're reducing risk in performance by the skill sets that are actually applying it as well.
Yeah, there's an interesting example. We do see some small amount of waste generated from EWI schemes across the UK with our retrofit product. But some EWI system holders are benefiting from our Rock Cycle program, where it's where we take back offcuts back to the factory, and it's a closed loop circular model where we recycle that then into new products.
Brilliant. Will, did you have anything you wanted to add there, or should we move
on?
Yeah,
no, it's an area that we're interested in. Obviously, Part Z is being mooted for the building regulations. So I'd agree with Rupert that the data isn't great. I don't think we've got a kind of full picture of it. And I think some of the methods are quite light touch and some of the more involved methods are quite expensive. But it's not just, like you say, it's not just the whole life carbon of the product you put in there. There's issues of circularity. There is issues, waste is as old as the hills. I think when I was a broader sustainability consultant, there was a statistic from DEFRA about the amount of construction waste that was just delivered to site and went straight in skips. So, it's that, and so there's a financial driver there as well as an environmental driver about some of the way that, we design, as Rupert points out, to avoid that kind of cutting and waste if we can, to manage our on-sites better so we're not wasting materials. So it plays into quite a lot of agendas, and some of them are, the traditional site and waste management, and some of them about material selection. But also, I think there's that broader sustainability of materials rather than just carbon. So, the toxicity, health, and all those types of issues that need to be thought about. So it's something we're working with the University of Manchester in this area at the moment, working with the new build developers.
Brilliant. So another question that we've had come in is around, sort of strategies that can be employed. Is there any, even if it's like your one piece of golden advice, or one or two, for the audience to be able to maintain continuity of insulation performance throughout the life cycle of a building, sort of from handover to initial planning to ongoing maintenance. Is there one thing that would sort of is a sort of key? And that might be a very simplistic way of looking at it. There's probably 8 things that are key, but what would be your top tip or top couple of tips?
Who wants to go first?
Well, do you want me to say? I'll be honest with you. We don't build or retrofit anything. We measure it and come back on it. So I think this is the one for the practitioner.
Okay. So I would say then, just reiterating a couple of things in the slides there. Well, keeping it simple, designing for buildability. If we can work all together, get feedback from the contractors on what works, what doesn't. How we can actually get that feedback loop working effectively are key elements. But let's work out strategies to get the best use or optimize the performance of the products that we're installing, so we're getting full value as opposed to half value.
Brilliant, thank you. I'm very conscious that we're rapidly running out of time, and we've covered quite a lot of ground. If you guys could see my notes, I've got pages and pages of notes from your presentations, because they were all so in-depth and wonderful with the knowledge that you shared with us. I think it'd be really helpful for our audience if you guys wouldn't mind sort of giving, between 1 and 3 key takeaways that you sort of want to leave with them at top of mind as we close out today's session. And again, thank you to our audience. You've been so engaged. There's been so many questions coming through, and we really appreciate your participation in today as well. So I'll hand over back to you guys. Does anyone particularly want to go first?
So, I think one key takeaway, and I think it's, Rupert and James is saying, is actually not a lot of this stuff isn't new. Some of it is, but some of it is about good site management, good design, skilled people doing great work. And that you can roll back 20 years to rethinking construction, and a lot of the lessons are still playing back. So for us, although we evaluate it, it's largely about the process. The products generally will perform as designed. It's when they get into the system, and so that kind of process and conversations and integration is key for us.
Absolutely. Rupert, James, does someone want to go next?
Yeah, just to say, reiterating what I said in the presentation, net zero places greater emphasis on the building fabric. And as we look to decarbonise the grid, fabrics need to work harder for longer. So insulation plays a major role in that. Not just about reducing operating costs, but sustainability and building better buildings, really, that are more comfortable and nicer to live in.
Brilliant. And Rupert?
Okay, from the insulation perspective then, and looking at a lot of the retrofit work that we've been looking at, we've been installing insulation in a lot of retrofit projects for a number of years, but we need to think about it in a slightly bigger picture in terms of how we can protect that insulation so it does its full job, because at the moment a lot of the insulation that's getting installed is getting bypassed. So we need to make sure that it's encapsulated, essentially protected from the wind and airtight, and the fabric as well.
Brilliant. Thank you so much. I'd love to say a huge thank you to James, Will and Rupert for giving up their time both today and in preparation for today's session. There's been some wonderful insights shared, and I'm sure there's been a lot of knowledge gained by the audience. On that point, as James said, if you want to delve further into this, please share your details in the chat, and we'll make sure that you get access to that CPD. Just as another note, this session and all our other sessions this week are CPD certified. So if you're trying to get your CPD points for the year, keep tuning in for Net Zero Live. We have another session at 2 p.m. today, and that's all about making the decision between retrofit and rebuilding. So do tune into that one as well, because that will just sure to be another great session chaired by our technical editor, Thomas Lane. And just to reiterate, this session is available on demand. Give us about 60 minutes from the conclusion of the session, and it will be available via the same link you joined today. So once again, thank you to our audience for your participation. Thank you to our speakers, and a special thanks to Rockwool for making today possible. Thank you all, and goodbye.